We see in this video, this is another video regarding differential equations and relating to velocity and acceleration. So in this example, we have a car that's going at 100 kilometers per hour, and then it decelerates suddenly, it brakes, and it decelerates at 10 meters per second squared. That's the deceleration. So first thing we got to do here is we got to convert. It's easier to deal with meters per second, so we'll just convert the 100 kilometers per hour. So we'll set this up here. As you can see, I did the calculation, and the velocity, which is 100 kilometers per hour in meters, will get 27.8 meters per second. And the acceleration is written right here, negative 10 meters per second squared, because it's decelerating. And this is the position. We're going to start at 0 because that's the start of our journey. That's when we're starting our calculation. It's from the moment of deceleration, and our initial position in that regard is 0. We're trying to see how far it goes at the end. So we're going to put 0 there. And the question is, how far does the car go at the end? If it has this velocity and it decelerates with this deceleration. So the first thing we got to do is we got to find the velocity. We got to find the velocity function from the acceleration function. So we know our initial velocity is this, but we got to find the velocity function so we can get to the position function. So we take the integral of negative 10, because that's our acceleration, and then we'll get this velocity function. We'll just add a t plus a constant 1. And we know that our initial velocity that we're speeding at is 27.8 meters per second. So we'll plug that in here, and then we'll get 27.8 for our C1. So at time 0, we're going at 27.8 meters per second. And so our constant at time 0 is 27.8. So we'll rewrite this as v of t is equal to negative 10t plus, instead of C1, we'll write 27.8 meters per second. So now the car stops at v equals 0. So we solve for time. So when time is equal to, when the velocity is equal to 0 is when the car stops moving, because there's no speed to it. So what's the time when the velocity is 0? So we set it equal to 0, and we solve for t. So we subtract negative 10t from both sides, divide by 10 on both sides, and we'll get t is equal to 2.78 seconds. That's our time for the entire journey. From the moment it starts decelerating to the moment it comes to a full stop, it takes 2.78 seconds, so 2.8 seconds. Now we can find the position function. We'll just have to take the integral of the velocity function. So once we do that, we get negative 5t, because remember there's an invisible 1 here, add 1, divide by 2, 10 divided by 2 is 5. We're left with t squared, but this turns to 5, and negative 5t squared. We'll add a t on, we'll get a t added to the constant here, and then we'll get another constant, which is c2. Here it was c1. And now the initial position is 0, as we set it equal to 0. So we set this equal to 0 to find what our c2 is, just like we did with the velocity, where we set right over here. Or sorry, we set the initial velocity to 0 so that we could find the c2. We set the initial position to 0 so we can find our c1, so we can find our c2. Sorry. So we set it equal to 0 so we can find our c2, and we get 0 is equal to c2, because this all turns to 0, this all turns to 0. We're just going to get c2 is equal to 0. And now the position equation, the final one, is equal to negative 5t squared plus 27.8t. Now we just got to plug in the final time for the entire journey, because that's how long the journey was, 2.78 seconds. And we'll get 2.78, x of 2.78 is equal to, and at the end we'll get 38.6 meters. So this car, if it was going at 100 kilometers per hour, and it brakes suddenly at 10 meters per second squared of deceleration, it'll go 38.6 meters in distance before coming to a full stop in 2.78 seconds. There you go.